Happy Monday, Algebra 1. As you know by now, I'm not here on campus today as of the release, I guess, or upload of this video. So I'm going to go over your notes today for writing equations and inequalities, day 1. The sub in my class today should have provided you with a paper copy, but I guess, well, yeah, actually it should. If for some reason there isn't any, please go next door to Mr. Velasquez and ask him if he has any copies, and he could probably help you out, but there should be some there left for the substitute. So in our notes today, we're going to continue studying inequalities that we started last week, and we're going to begin just writing inequalities that represent real-world scenarios or pseudo-real-world scenarios, and so that we can apply them to real life, and then we're going to end up solving them using the methods we learned last week. So in the beginning of our notes on the top here, you see we have a little table here of keywords associated with each of the inequality symbols as well as the equal sign. So we have the less than symbol, which is pronounced less than, and sometimes associated with the phrase fewer than. Greater than symbol, which is also associated with more than or the words exceeds. Less than or equal to, which could also be related to no more than or at most. Greater than or equal to is also associated with no less than or at least. And then we have the equal sign. A lot of times it's the word is or the total or will be or final or whatever. So it's usually a summation type of phrase. But a lot of these, you can gauge what they really mean when you read the context of the scenario. And that's exactly what we're going to do today. So I have to do my notes digitally because my document camera that I would just normally write with, and you guys can see my writing and everything, just will not connect to my computer here at home. So I have to go ahead and just kind of do this digitally like I would when we were doing the online teaching from last year. So it might take me a little longer. You guys can do this by hand, so it might take me a little longer to type everything out as opposed to you writing it, which is one of the benefits of you having a paper copy in the classroom. So without any further explanations, get into this assignment. Today we're going to write equations and inequalities. We're going to highlight the important information and keywords that you need to write the equation or inequality. So our first scenario here says, Robert had money in his savings account. He spent $35 of it on a new jacket. He has $70 left. Write an equation, that means an equal sign, that represents this situation. All right, so what we do know, I guess by the initial onset, is that he has money in his savings account. They don't tell us directly what it is, so we'll just call it X. When my X went down there for some reason, and I don't know why that happened. Let's go back up here. X, all right? And then we know that he spent $35. So that's minus 35 from his total amount. And then he bought a new jacket, and then he had a remainder of $70 after that expenditure. So we were asked to write an equation that represents the situation, and there it is, pretty easy. Now we're asked, how much money did Robert have in his savings account before he bought the jacket? Now, it's pretty intuitive, I think, for most of us. We know what's going to happen, but let's go ahead and do the work anyways. So we have this equation, and we're going to basically work it backwards to go ahead and solve. So my variable is X. We're subtracting 35. So the opposite of subtracting 35 would be to add 35 to both sides. So we're going to go ahead and say plus 35 on the left side of the equal sign and plus 35 on the, whoops, get the plus sign there, on the other side of the equal sign. When we do that, we come down another line. We have X minus 35 plus 35 cancel out. We have the equal sign falls down, and 70 plus 35 is $105. Excuse me. So that's how much money he has left. He had in his savings account before he bought the jacket, $105. So there's an equation representing a story, and then we solved it using the skills we learned from the last week or so to determine the solution. So pretty basic, pretty easy, and that's what we're going to do today. Next example, Keith has $500 in the savings account at the beginning of the summer. He wants to have at least $200 in the account by the end of the summer. He withdraws $25 each week for food, clothes, and movie tickets. Wow, he goes and shops every week. That's a good amount, right? And inequality represents Keith's situation. Now, obviously, I can't even imagine going to the movies, buying clothes and food for $25 a week. But let's pretend this is like, I don't know, 50, 60 years ago, maybe even more. Then that's doable. What a great little life he has. So he's making pretty good money. So let's go ahead and take what we do know. We want to write an inequality, which means we're going to use one of those little arrow symbols to represent this situation. So what do we know? He has $500 initially. So I'll go ahead and kind of, now you can go ahead and highlight, circle it on your paper. I'll kind of just, write it down right here. $500. And he wants to have at least $200 in the account by the end of summer. So if he wants to have at least $200, let's set that money aside. And that means he has a total of $300 to spend. All right. So that's kind of like the goal we're working for. Now, what we also know, whoops, I want to do something really quick. There we go. What we also know is that he's going to be spending or withdrawing $25 a week for food and all his fun. Write an inequality that represents this situation. So here's how we'll begin our inequality. We know that he's getting $25 for X number of weeks, because they don't tell us exactly how many weeks, but $25 a week, and he has to have spent no more than $300 by the end of this entire experience. So the symbol we're going to use for that would be less than or equal to. Let me get this going really quick. Oops, I hate that it moves around. Sorry about that. Get my symbol put in there. All right, so I have it all big and blown up on purpose, and not just to be weird. And that's because, so the amount of $25 of, I guess, self-allowance he's giving himself has to be equal to or less than the total of $300 that he's willing to spend, because he wants to have savings of $200 left over. So he cannot pass this barrier of $300. So $25 allowance a week for up to, which means equaling, or less than $300 is spent. All right, now we're asked how many weeks can Keith withdraw money from his account. So basically we're asked to solve it. All right, so let's go ahead and we'll do that here in the next line. So we have this, we have 25 times x is less than or equal to 300. Well, what undoes multiplying by 25? That would be dividing by 25. So I'll put divided by 25 on the right over here. I used a little slash because getting a fraction bar would be next to impossible. Divide by 25 on that right side. And then when we do that, 25 goes into 25 one time. So I have 1x. I have my little symbol, not so little symbol really, right here. It comes down. I did not divide or multiply by a negative number. Therefore, I'm not going to have a switching in direction of the symbol, because remember we learned that last week as well. And then I'm going to have 300 divided by 25 is going to be 12. Oops, I don't want it bold. 12 weeks. Because we need to assign a unit. What are we measuring? 12 weeks. Because this is a real world scenario. So real world scenario should have units attached or things attached that you're counting. Just like in the first example, we had $105. Here we have 12 weeks. So X equals the number of weeks he can withdraw or pay himself this $25 allowance. You can do it for 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Any 12-week period he wants. He can skip one. As long as he gets no more than 12 total weeks of self-allowance, he can keep up this nice little fun lifestyle he's created for himself. All right, so go ahead and write that in your notes as well. And our final example, and this is going to let me know who's actually paying attention and doing the video notes. Notice I made an edit in red there on the left. We're changing one of the numbers in the story to 0.75. So for number 3, it reads, Yellow Cab Taxi charges a $1.75 flat rate in addition to 75 cents per mile. Katie has no more than $10 to spend on a ride. Write an inequality that represents Katie's situation. So we have two things happening in this story. So therefore, we're going to have a two-step equation. We know, first of all, that just for getting into the taxi and riding it, she's charged automatically $1.75 as part of her fee. On top of that, she's going to be charged 75 cents for every mile. And we don't know how many miles she's driving or going to be driven. But we know that that amount that she's going to spend total, she can spend all $10 or she can spend less than $10, but she can't spend more than what she has. So similar to the problem above, we're going to have that symbol again right there. And then we'll go ahead and bring it back down to normal human size for the rest of this. And she can't spend any more than $10. So the amount she's going to be able to afford is $1.75 plus 75 cents for X miles. As long as that amount is equal to or less than $10, she'll be good. Now, just like the previous problems, we're asked to go ahead and solve it. So let me go ahead and bring it down here. And we'll first begin by we have to get rid of this, the stuff furthest from the X, which is this positive 175. So we'll subtract 175 from both sides of the equation. And make it a little more dramatic, I guess, or more balanced like we did in algebra. Put it right there too. All right. And then next line. After that, the 0.75 cents per mile falls down. My inequality symbol is going to fall down. And then 10 minus 175 is going to be 8.25. I'm doing this on purpose because I want to fit that big symbol in there without having to spend all the time editing the shape of the symbol. All right. So then now we have to divide both sides by 0.75 cents, basically. So I'll divide the right side by 0.75, as well as the left side by 0.75. I'm going to do a quick little edit just to make it a little more mathematically accurate and easier to understand what I'm doing, hopefully. And then finally I end up with, and I'm kind of running out of space here, so let me go ahead and just bring everything up a line. There we go. So on the left side, 0.75 divided by 0.75 leaves me with 1x. I have my big old symbol right here. And I believe, I guess let's go ahead and do it like that. And then we're going to have 8.25 divided by 0.75. So I'm hoping you guys already have calculators in hand because you need to make that a little habit when you get to class. But 8.25 divided by 0.75, I do believe is going to be, is it 11? Let me double check really quick. I did the math. Yeah, it is 11, but not just 11. It's going to be 11 miles. So hopefully she lives within that 11-mile radius that she can afford to be driven. If not, she's going to have to do some extra walking, but heck, if her house, I guess, or her home the place she's going to is more than 11 miles away, at least she's 11 miles closer with the ride before she has to start hoofing it. All right, so those are 3 examples of the kind of what you're going to do today. Along with these notes that you need to complete, preferably in class, you're going to have a POD that you need to complete at the beginning of class, and then, well, before the end of class for sure. And then you have an assignment here based on talking about the things we talked about in this lesson and some concepts related to it. All right, so best of luck. If you have any questions, I'll be back on Tuesday, tomorrow, for you guys. So please just relax, be good for the sub, be good like you always are for me, and I'll see you guys next time. Have a great rest of your day. I'll see you tomorrow. Bye, guys.